form. Here you go. I'll clip this front part out probably. Mr. Edwards, good morning. This is Damon from Trailer Made Trailers. Sandy's holding the camera. This is my operations manager filming today. We're going to show you inside and outside the attachments and kind of how to clean all this up. So let's start under here, Sandy. So the 2x6 should be right here, and it goes up underneath the sill plate of the trailer or the angle flange. And then is there good lighting where they can see where the flashing starts? Okay.
Yeah, flashing and screws.
We've been this flashing. It's 3 or 4 inches at 90 and then a 180 down and then a 1/2 inch drip edge. And then behind this is the 2x6 or is it 2x6? Yeah, 2x6 and poly ISO. And then we just shoot some self tappers up into it.
And we run the HDT through 4 bolts all the way through.
Oh, we do this through?
Yeah.
Okay. Well, we've done it both ways, right? That's what I explained to him yesterday.
Yeah, both ways.
So it's kind of builder's choice. If you want to shoot a longer bolt through there, you can sandwich the 2x6 and the bottom plate of the wall. Just do that with a longer bolt through an HTT4 anchor. Some have come, maybe it's mid-seasonal or something, or we didn't know, or a retrofit, or if you've already got the walls up and the anchor bolts are in for the walls, you can relief the tops of the 2x6s with an 1.25 inch or so spade bit, and just kind of lay those out and let it sit down over the proud bolt heads sticking out from the bottom here, and then shoot the 2x6 up with some poly ISO in between it and the trailer, and that's your thermal break. Let's go inside so we can show them some of these anchors. Okay, so first anchors, like here in our corner, this is what I was talking about yesterday on the telephone. This is an HTT Simpson anchor. This is a 1/2 inch bolt that comes up from the sill plate of the trailer, and the bottom plate gets bolted down. Now, you had asked, if you would back up over here to this bay, do we nail in between bays, in between anchor bolts? And yes, we put a 1/4x20 deck screw with a fender washer, and that sucks the sill to the bottom plate and holds it tight. It's almost like a kind of a countersunk screw. Well, it is. It's a floor deck screw. So where you have the exterior flange and you can drill holes with your mag drill there, then you come over here, this sill plate's inboard. So this is on the inside of the trailer edge. And this is the RCK and the RCK stiffener. These are some Simpson parts that I can get you so you can put these down, and we shoot 2 pilot holes and then 2 1/4 inch bolts into the sill. Right in the middle, there's a tube in the front and an angle on the inside of the trailer, and that gives you a 5 inch sill, and that lets you have well enough to land here, still support your underlayment. Inside here, it probably comes out about right there, doesn't it, Sandy?
Yes.
Just about even with the first anchor bolt. Yeah. So
it's a total of 5 inches from the outside of the trailer.
Right. Yeah. 5 in, and we're 3 5/8 to here. So you got another 1.25 inches or so to get there. Okay. Ugh, I'm getting old. Over the fenders, this would be the same thing. You can't put you can, but it's nonsense to put a HTT here. So just use an RCK with those 1/4x20 screws and then break them off underneath the fender. And these fender boxes are structural. This is, that's a triple. So that's 3/8 with gussets. And we'll show you that on the outside too. What else? Show them zoom in on the kind of like the layout. Like you see here, there's, don't show them all the mishits. The stick number, panel, and location are all on the drawings and all on each stick of the kit, Bill. And like here, hit that loft. You see, it just tells you it's a loft roof. It is kind of like paint by number, if you want to think of it that way. And it gives you a very, very clear path forward. You have sticks that turn into panels, and then you have panels that turn into a box, and then you have another panel that goes in as a lid on the box, and then it's done. So the other cool thing is we've done all the engineering, so we know what clips go in the kit after it comes out of our machine. It gives us locations of where they're supposed to put Simpson anchors, hurricane ties, and all of these rafters overhead are I-beam. So there's C channels that are back to back. And you can walk on this roof pretty doggone well. I think it's, what's standard, 72 is our standard roof load.
Yeah.
72 on an 8. And I think it's 68 on a 10. Yeah, that's pounds per foot up top before we do any special tweaking or tuning on it. So it handles, high elevation Colorado snow loads. It'll take care of whatever you guys have there in the Midwest. If you can get auger bolts into the ground deep enough, I would trust this in a Missouri tornado, no problem, because it's built out of steel. Outside here, I just wanted to tell you really quick to bring back about the fenders. Structural steel with gussets. No matter, they're what, 3 foot on center, I think those are. Yeah, 36 on center. The drip edge that we roll here, it goes all the way around 360, and then you start your first course of siding just over the top of that. Notch it out for the fenders. Use Protecto wrap or some kind of flashing tape to button everything up. And gosh, I think that's about it. These guys actually did a pretty nice job hiding everything from me. But remember that right behind here, you've got 2x6 and a what do you use, a half inch polyiso R3. It's SI board, but it's R3, and that's enough with the 2x6. You can screw it, or you can sandwich it all together and bolt it down from the top. And that should just about do it. If you want to see that, do we have it drawn, or do we just kind of have it in a pocket? The notes for how to.
I'm not sure. There was a drawing over the brakes at one time. I'm not sure if it's still there.
We'll go look and see. We'll see if we can get you a drawing of that, and if we can, that'll be helpful for your guys if they want to bend some sheet metal, or if you want to teach some students how to bend this sheet metal. It's something you can do on a handbrake with very light gauge, 24, 26, or even, what is that, 28?
No, I think that's 20.
It's thinner. Well, maybe. Let's see.
Yeah, it might be thinner.
That's thinner. It's 20, 24, I think. Yeah. So we buy some inexpensive stuff from the mill whenever they have it laying around. Like if it's drop and it's an oddball size, we can use it as flashing. So we buy it kind of on the cheap, and we've got rolls and rolls of it, so it's kind of atypical, but we roll the dimension basically the same. We might get a little bit more or less up and down and under, but I think it's about a 10 1/4, 10 1/8 inch.
Right.
Yeah, like a 10-ish wide inch ribbon of light gauge steel, and cut it to whatever width your brake is, 4 foot or 8 foot, and or 10, and do the bend profiles. That's a good trade skill to have, bending some sheet metal to flash out houses or roofs and things. So something to consider when hopefully you're coming out. We'll talk about that after you get this video. I can't see any. Can you think of anything else they need to know?
I don't think so. Yeah.
We've got. I'm not wild about Zipboard myself, and that's no dig on it. It's just not my preference for this. For every project, I'd say it's good for some, but this one's going to be a highly mobile unit in city, and there's a lot of excess weight on the outside of that thing that I think could have been shored up by using like that SI Strong or something. So let me show you that product really quick since we're out here. This is it. It's Ox Engineering. Give them a logo of that. But this is structural insulated sheathing. They used to call it, oh, they do call it SI Strong, and now it's something new. But Ox-IS, I think is what we used to call it, or is that the new name? I don't even.
That's the new name.
That's Ox-IS is the new name. This is the old name, SI Strong, and this is what it is. It's basically 3/16 press veneer. This gives you 7/16 OSB equivalent for shear. 1/2 inch of polyiso bonded to the outside of it. Your moisture wrap is on when you tape it up, and then there's here you can see the outside is your radiant heat barrier. So it's your heat wrap. It's got your moisture barrier on it. It's got R3 on the outside face of the studs, and it's crazy light. So the secret sauce is in the glue that they make that backer board with. But this is basically an insulated red thermoply, same company. This is red T-ply with polyiso and a wrap on the outside of it, and it's priced equivalent to green zip board, but less than 30% of the dead weight on the structure. So for 53 pounds a sheet, this is like 22, I think. Isn't that what it is? This is, I think they tell us this is 22 pounds of a sheet, but this is 56 or 65, like those two numbers. Anyway, this is a one-person installation job. You can cut it with a utility knife if you had to, or even a little finished skill saw blade. Takes this, you hold it up with your knee and follow the pin schedule. We shoot all this stuff up with an air nailer. So we'll pause for just a second, or we can walk in and just keep it rolling, because we'll walk in and show. We got some tools out probably to show them the pins and that sort of thing. Rocking the oldies. Oh, here's one right here. Let me get this open real quick. Try and do this one-handed. So this is our secret sauce. These pins are ballistic tipped, and they are twist shank, if you will. It's a tight rifling, and this shoots in with, what do we run these at? About 100 psi. Yes. Just little higher than your standard nailing down shingles or siding, but this is a 15-degree coil-fed gun, roofer sider, a little heavier duty because it's by Nail Pro, kind of purpose built for what we do, which is striking steel studs. Your Hiltis, your DeWalt's, your Bosch, all those guys with a nailer side, roofer sider, they'll still get through a few jobs. They'll just take a little more wear and tear than these do. These are kind of built a little more robust to do this. And I don't know, have we ever sent one in? And
not any of these Nail Pros.
No, none of these Nail Pros have even been in for a rebuild or a seal kit yet. So they're about $500 at Empire Staple. That's who we vend through on this, and the pins. And the pins are about $140 a case, I think, something like that.
They're about $95.
Oh, okay, they're a little cheaper. So Sandy said they're just under $100 from Empire. So you get a couple cases of those, and you're off and running. But people ask us all the time, like, well, how do I hang stuff to steel? And I say, just nail it. And they look at me like I got three heads. But this is really what we do. And 82 pounds of pull strength per pin is what we have engineered. And that the pin is designed to go in like an ear pierce, kind of spread the earlobe out rather than shoot an exit wound out of the back of it, so that it doesn't lose any of its hold strength. And it essentially, when the steel collapses around the pin, after it pins in and rifles through, it cold welds itself shut. And everybody here can tell you what a disaster it is to have to to take a sheet off after you've got it on just a little crooked and you got 20 pins in that thing. It's almost better to just knock the whole sheet out from the outside in and then start over. But you're cutting nail heads off. I mean, it's something else.
The pins don't come out; they'll rip through the board.
Yeah, they will. They'll. That's it. The board will pull off around the board or around the pin, and then you cut the pins off the face of the studs. So, if anybody's ever worried about can you nail to steel, it's yes, but measure twice, nail once is good practice. Let's go show them in this one really quick. This is a 10 wide. It's a deck over configuration, and I'm going to stand here relative. I'm 5'9", about 5'8.5" probably these days. But here is my waist. So this is what your effective step-in height's right here. So, sorry. It's the only place I could have put my foot on top of your string, all right? I'm so sorry. This is a kit in a different configuration next to the one we'll show you next. But this is an entire kit of walls disassembled. So we assembled all the walls in about a day. Then we stood them up the next day, put the roof on and sheathed it up. And now the guys are siding it out. Later in its life, it'll be turned into, hold on. Later in its life, after we turn the rock concert down, it's going to get turned into a mother-in-law suite. But today, it's going to be a storage box for a job site, and then they'll come back at a later date, show them the contrast between just the one that's nothing but sheet metal, and then show them the front of the one as it's going to live later life. So it'll kind of start as a storage unit, and then later on it's going to become like this granny pod or mother-in-law suite. This is a modular unit that comes off the trailer. So this is a 2-piece deck over. This goes back and gets another unit or another piece. This unbolts and sits down on a set of piers and stays behind. And this is engineered. We've got that already approved in a handful of counties around us where we're going to set this. But this is a great ski shack or mountain cabin or lake house idea for not a ton of money. And it won't rot and deteriorate like a mobile home will or like a always. There's perfection being done here, so we're tapping right when I'm talking. I love it. But this is essentially IRC modular. This is the code that it would be built to, but we sort of downgrade it to ANSI code 119.5, which is Park Model RV. Fewer steps to get that code and put a piece of structure on a piece of land. So this fits the most situations in the most cases without having to go to the city and get your plans approved and yada, yada, yada. So a lot of times this goes from send me a foundation and a site plan and bring in this prefab structure. Once it goes on the foundation, now it's real estate. But there's a bit of a loophole there, and that would be beneficial to a lot of people in your neck of the woods where they have, they have lake houses or got a lake property and don't know how to cost effectively get something built there that they don't have to keep going back every couple of years and rebuilding or keep, over repairing and things. So this is a really good opportunity for that. And your students could build those and the school could, monetize that and reinvest that disbursement each year once you sell that type of model back into the program like our other schools do. So that's something to consider. And we can talk about that in detail when you come out, but just to kind of give you a little bit of a walkthrough here. I hope what we showed you with the foundation, kind of the Oreo cookie and how we build it, I hope that helps. Do we have another one here without it? These are going to California, so we didn't put a brake under these, did we? So this is just steel. Here's our flashing, and this goes underneath the siding like I showed you outside. Everything's the same except there's no 2x6. This is just directly to steel because this is a temporary siding. These guys are going to take this all off, and then they're going to retrofit by putting a 2x6 under there and then starting their siding a little lower once they're on site out in California. Once they're done being used as like storage units. So these are essentially Connex boxes with pre-cut windows and door holes ready to be repurposed once they're done being Connex boxes. But this, I'm glad I stopped to see that. This is like a bare bones attachment, and you can see the bolts, roughly every 4 foot on center. That's going up through a Simpson HTT4 strong tie anchor. I think there's one. There should be one back here somewhere. Am I just missing it?
It's down just a little.
Oh, I see it. There it is. Yeah. Yeah, my spatial awareness is terrible today. Oh, there's a wall break there, so he'll put one back to back. And these are all IRC zone 5 through 8 climate zone built. So 90, 100, 110 mile an hour wind, 130 pound roof load on this one. What is 136? Yeah, this one behind us. Yeah, this is on a 312. It had to be 136 or 138 PSF on the live load of the roof of that thing. It was crazy, but we can do that all out of our light gauge steel. It's what's cool. Without having to give up height. We're not going to a 2x10 rafter to achieve that engineering need. We got that done with a 2x4, didn't we? A heavier gauge. Yeah, 18 gauge I-beam 2x4 nominal, 3 and 5/8 back-to-back C channel. On 16s? Yeah, we still kept it on 16s. So we did that with only about a 10 or 12% add to weight, but no loss in the loft. So we kept our ceiling up nice and tight. Still got R30 on the ceiling, R30 in the walls, R42 in the floor with closed cell spray foam and all metal structure. And they're as tight as a Yeti cooler. And that's good and bad if you're not careful. So good ventilation, keep the moisture under control. That's important. And the kids can build, the 21st century tiny house on wheels. This is the direction a lot of this is going. Since we're out here, I'll show you. Companies like mine are way bigger companies, actually. I've been in this over 10 years, but the bigger thing, large construction companies are figuring out what I've known for the last 10 years, and other guys that have known longer than us that have been in cold form steel rolling. But this is like the sawmill, the lumber yard, and the forest all in one. So this is the sawmill. Here's the lumber yard. And here's the forest. So we make sticks whenever we need them. We just plant our little steel trees here. They grow instantly through that big orange machine and spit out the other end CFS sticks that are plus or minus 30 thousandths tolerance in all directions, all axes. And it's not terribly expensive, and steel is not typically as volatile as lumber in the market. So when they shift, the steel goes up 10, 20%, but we've seen lumber swing 300% in a year. So this is becoming fixed cost operation for construction companies and large GCs. They can buy a couple of these, hire some technicians that manufacture in-house. They can cut costs in several areas, control quality and production and output and profitability, frankly. So why would they go to the place that the market is more volatile? They can fix prices on this, much more closely, build a better product. This stuff can all be insulated. So I can put insulation in here and turn this into an R25 stick. And a piece of 2x4 lumber is only R3 no matter what you do with it. And it's still 1 5/8 wide. Every 16 inches as a vent in your wall system. So when people ask, well, steel's cold and it's a terrible, it's a terrible insulator, yeah, well, that's true. Steel is cold. In fact, it's very cold now, and it's a thermal conductor. It moves energy through it well. But we're only going through 38 thousandths of an inch at a time every 16 inches instead of 1 5/8 every 16 inches, because effectively 1.5 inches on 16s means you've only got 13 inches of insulation in between two breaks in your envelope, and then you repeat. So the truth is, steel is about 22% thermally more efficient and tighter as an envelope than today's stick framing is. Even advanced framing, 2x6, lead platinum. I can get lead platinum out of a 20 gauge 2x4, which is R25 in the walls. So we can do that with this system, and your kids can click it together like an erector set. It's pretty cool. So if you're interested, let us know. We'll roll out the red carpet. If you want to bring somebody out and come tour the factory and see what we do, kick the tires, so they say, please do. Love to see you. Thank you.